So thanks very much for coming to this first session of the third day of the GSE UK virtual conference. This is the 7th session of the IMS stream and the first session for today. And it is on understanding how a CM0 SL1 input message is sent to the IMS Connect works. So this is a suite of, there were 2 other presentations, two on Tuesday, and this completes the round of the in-depth analysis of the messaging for IMS Connect. And I'm glad to have Subhadesh Sakar back from BMC to talk this one through. And if you've got any questions during the session, then please just ask them verbally and just make sure you can, to unmute yourself. So Subhadesh Sakar has been in BMC for I think over 7 years now, and he's been in the IT industry supporting IBM Z mainframes for over 15 years. So without further ado, I'll pass you over to Subhadesh for this presentation.
Hey, thank you, Tom. Thanks everybody who has joined in and who is going to listen to this in their spare time in the future. Thanks for taking the time out. So yes, as Tom mentioned, this is the 3rd session of a series of sessions on how IMS Connect OTMA processes the messages that are sent to OTMA by an OTMA client. In our case, it's an IMS Connect client, since we're talking about IMS Connect and OTMA combination over here. Let me go straight to the presentation, and I'll just try to pull this down. Okay. Yeah. So today's session, I'm going to talk about how a CM0 SL1 input message sent to IMS Connect works. And before I start the session, just a short introduction. My name is Shubhashish. As Tom said, I'm a senior product manager looking after the BMC AME data for IMS portfolio of products and solutions. Okay, so with that, let's talk about what this session is all about and what's in this session for you all. So in this session, I'll talk about what exactly happens when an IMS Connect client sends a CM0 SL1 ACK input message to IMS Connect, and the sync point completes successfully. I will also explain the case when an IMS Connect client sends a CM0 SL1 input message to IMS Connect, but this time a client NAC occurs, or a client negative acknowledgement occurs. And finally, I am going to talk about a case which is actually not, quote unquote, related to CM0 SL1 messages, but I thought that it's a good way to end the series of talks. And it would be sort of incomplete if I don't cover the 3rd case, which is what happens when an IMS Connect client sends an input message. And I'm stressing on a generic input message here. I'm not talking about CM0 or CM1 or SL0, SL1. It's a generic input message. It could be CM0, CM1, SL0, SL1, doesn't matter. It's an input message which an IMS Connect client sends to IMS Connect, but the input message is NAC'd by OTMA itself. So we even do not go down to the level of the application program processing the input message. The input message is nacked before even the application program, IMS application program comes into picture. So the input message gets nacked by OTMA itself. So I thought that it would be a nice way to end this complete series of talks um, after going through this third and the final use case, or the message protocol. So with that, let's start, and let's start with the generic case. What happens when an IMS Connect client sends a CM0 SL1 input message to IMS Connect? Right. And let's talk about this generic case first, and then I'll branch out into the individual subdivisions. So what I mean by individual subdivisions is the sync point completes successfully is one branch of this tree, and maybe the second branch of the tree could be a client knacks the a client knack occurs, a client negative acknowledgement occurs. So these are the two branches maybe we can take. But before we go down those individual branches, there are a few number of common steps that we should actually talk about, and which apply to the generic case of an IMS Connect client sending a CM0 SL1 input message to IMS Connect. So let's get down into those steps first, and then we'll branch out into the individual cases as and when as and when the need arises. So if you have followed my other two sessions on Tuesday, I before getting into the technical details, I'd generally introduce the topic, but it would be a short introduction just to level set the discussion. So IMS Connect, or sometimes I prefer calling it Icon as well. So you might hear me exchanging those two terms, but those mean the same thing. IMS Connect or Icon is the TCP/IP gateway for IMS. So, besides running the traditional IMS transactions on ZOS, an IMS programmer or DBA can now leverage applications running on the distributed side of the world, right? For example, a Java web application. And they can leverage these applications running on the distributed side of the world to be able to easily talk to IMS databases. So let's consider the example of a Java web application, which will actually go through IMS Connect to IMS as an OTMA transaction, or an Open Transaction Manager Access transaction, OTMA. So commit mode and synchronization or sync level are some protocols that OTMA clients have to stick to. And all OTMA clients need to stick to the commit mode and the sync level protocols. The IMS OTMA client communicates information to IMS, and it also receives information from IMS in a prefix which is passed in front of the message or IMS command. Among the different levels and complexities of information that are present in the prefix are two levels of information which we are interested in for the sake of this session, and those information that we are interested in are commit mode and synchronization or sync level. So there are two levels of commit mode. One is CM1 or commit mode 1, and the other is CM0 or commit mode 0. So my first two sessions in the series, which happened on Tuesday, actually talked about the CM1 protocol, the commit mode 1 protocol. But today we are going to talk about the CM0 or the commit mode 0 protocol. So CM0 stands for commit mode 0, as I have said, which is the commit then send commit mode. This is actually the opposite of CM1, which was send then commit, right? So IMS sends out the response first, and then it proceeds with the sync point processing of the unit of work. But for commit mode 0, it's the commit then send commit mode. So IMS commits the unit of work, or the sync point processing has to complete first before the response message is sent out to the IMS Connect client. And as you can understand, this is quite a different beast from the CM1 protocol. This session is the steps that we are going to take a look at in this session will be somewhat different from what we looked at in my previous 2 sessions on Tuesday. So similarly, SL1 and SL1 should be, I have talked about this SL1 in my previous sessions also. So this is not new for this particular session, but anyways, SL1 stands for synchronization or sync level 1. And I'll explain in this session how all these things gel up together, right? So for SL1 or sync level 1, when the OTMA client gets the reply message, it must send an acknowledgement or an ACK message, or a negative acknowledgement or a NACK message for the sync point to continue. However, the OTMA client, it should still not process the reply message until it receives what we call the deallocate response message back from IMS, right? So in short, for SL1, the OTMA client must send an ACK or a positive acknowledgement, or a NACK negative acknowledgement for the output or reply message. IMS Connect will send the output reply message to the icon client, IMS Connect client, and wait for the ACK or NACK from the icon client, which is then sent by IMS Connect back to OTMA. And obviously, there is a timeout feature in OTMA while waiting for the ACK or the NACK message, because as you can clearly understand, it doesn't make sense for OTMA to indefinitely wait for the ACK or the NACK message, because the OTMA client might have gone down due to some reasons. Maybe the TCP/IP connection has broken down, in the environment, client environment, right? And so it doesn't make sense for OTMA to indefinitely wait for those ACK or NACK messages from the OTMA client. And there is a timeout feature in OTMA, which you can tune as per the requirements in your shop. And the OTMA will actually wait till that particular timeout feature gets expired for the ACK or the NACK message from the client. Now, we'll now try to understand in detail what exactly happens when an IMS Connect client sends a CM0 SL1 input message to IMS Connect. So to start with, the IMS Connect client sends a CM0 SL1 input message to IMS Connect. And then IMS Connect will build a control block, which is called the SVT control block for the client, if it does not already exist, and will send the input message to IMS OTMA through XCF, the cross-system coupling facility. Now, the transaction pipe or the T-pipe name would be the client ID, and I will actually try to note down the differences between the CM0 protocol and the CM1 protocol. So as I have mentioned, both my sessions on Tuesday were about the CM1 protocol. So if you remember, for the CM1 protocol, the transaction pipe or the T-pipe name is dynamically generated according to the port number which receives the input message. That is for the CM1 protocol. But for this protocol, which is the CM0 protocol that we are talking about, The transaction pipe or the T pipe name is actually the client ID. So that's one of the first distinctions that we have come about between these two commit mode protocols. Next, OTMA starts processing the input message because it has received the input message from IMS Connect. Now, the obvious choice is that it starts processing the input message. It allocates a control block, which is called a transaction instance block or a TIB. Depending on the level of security setup, it does a few more things, including calling RACF or any other system authorization facility or SAF product that is installed in your shop. The input message will then be inserted into the IMS message queue, and then it will be enqueued on the transaction queue, right? And after the input message is enqueued on the transaction queue, OTMA will free the TIB control block. Next, what happens is the IMS application program will do a get unique or a GU to the IOPCB, the input output program communications block, in order to retrieve the input message. The input message will be processed by the IMS application program as per the existing logic that has been coded within the application program in order to handle that particular transaction. Then next, the IMS application program will do an insert or an ISRT of the reply message to the IOPCB, and the reply message will be enqueued on a temporary queue. So after the IMS application program inserts the reply message to the IOPCB, the reply message gets enqueued on a temporary queue. And the IMS application program at this point reaches a sync point. Why? Because as you know, it does a GU IOPCB, it does an insert to IOPCB. So naturally, the IMS application program at this point it reaches a sync point. So the sync point proceeds further. So the processing of the sync point starts at this point. OTMA enqueues the reply message on a QAB, queue anchor block. So this is something, the queue anchor block is something which we are encountering for the first time. We didn't encounter this QAB structure or the queue anchor block structure when we talked about CM1 protocol. So after the sync point processing starts, OTMA enqueues the reply message on a QAB, the queue anchor block. Remember, I said that after the application program did an insert of the reply message to the IOPCB, the reply message was enqueued on a temporary queue. So now, after the sync point processing starts, OTMA actually enqueues that reply message on a QAB, queue anchor block. And by the name, you probably can guess that this queue anchor block is basically it's an allocation of memory. It's a queue in memory which actually anchors the temporary queue on which the reply message is enqueued. Right. So it's basically a queue chain, if you may call it. Next, what happens is the sync point is successful, and the sync point is completed. Next, so remember this we are talking about CM0 protocol, which is commit then send, right? So now, as you can understand, once the sync point completes, the commit process has ended. Now IMS is in a stage where it can actually send out the reply message back to the IMS Connect client. So IMS OTMA, after the sync point process completes, IMS OTMA will do an internal GU, internal get unique, to retrieve the reply message from the IMS message queue. And IMS OTMA will send the reply message to IMS Connect through XCF. IMS Connect will anchor the reply message on the SVT control block. And then IMS Connect will send the reply message to the IMS Connect client, and it will wait for the ACK or NAK message reply from the client. Now, till this point, all the steps that I have talked about till this point applies to the common situation when an IMS Connect client sends a CM0 SL1 input message to IMS Connect. And now we are going to take two branches. So the first branch is obviously, the sync point has completed successfully. So what happens in that case? In that case, the IMS Connect client, or let me correct it. The first branch is the IMS Connect client sends out an ACK message, right? So IMS Connect sent the reply message to the IMS Connect client, and it was waiting for the ACK or the NAK reply message from the client, right? So from here, we will take two different branches, two separate branches. The first branch is the IMS Connect client sends an ACK message. So the IMS Connect client receives the reply message from IMS Connect, and then it sends out an ACK reply message back to IMS Connect. So this is the first branch that we are taking. The IMS Connect client can then go ahead and process the reply message. Very simple, because it has sent out a positive acknowledgement back to IMS Connect, which means that it is now ready to go ahead and process the reply message that it has received from IMS and then IMS Connect. IMS Connect will send the ACK reply message to OTMA through XCF, and OTMA can then safely go ahead and dequeue the reply message. Remember, OTMA had enqueued the reply message on the queue anchor block till this point, because it had not received any confirmation back from the IMS Connect client. So it couldn't take any decision as to what it should do in terms of the reply message. So it had enqueued the reply message on the queue anchor block. But now that the IMS Connect client has sent an ACK reply message to IMS, or OTMA in this case, OTMA can now safely go ahead and dequeue the reply message. So this is the completion of the first branch, which is IMS Connect client sending a CM0 SL1 ACK input message to IMS Connect, and the sync point completing successfully. Now let's go through the second branch. The second branch is the client, instead of sending a positive acknowledgement or an ACK, this time the IMS Connect client sends a NAK, or a negative acknowledgement, right? So the IMS Connect client receives the reply message from IMS Connect, and then it sends out a negative reply message or a NAK message back to IMS Connect. The IMS Connect client notifies the user. Remember, since the IMS Connect client has sent out a NAK this time, it cannot go ahead and process the reply message, right? Because there is some malfunction somewhere in the process. So the IMS Connect client will notify the user of that particular malfunction. IMS Connect sends out the NAK message to OTMA, and then OTMA requeues or purges or reroutes the reply message, right? So, and this completes the second branch as well. So in short, we have talked about what happens when an IMS Connect client sends a CM0 SL1 input message to IMS Connect, and first branch, the IMS Connect client sends out a positive acknowledgement or an ACK message back to OTMA, and the second branch, the IMS Connect client sends out a negative acknowledgement or a NAK message to OTMA. So to conclude, IMS Connect sends the output reply message to the IMS Connect client, and it waits for the ACK or NAK message from the IMS Connect client. Once IMS Connect receives the ACK or NACK message from the IMS Connect client, it sends the ACK or NACK message to OTMA. And obviously there is a timeout feature in OTMA while waiting for the ACK or the NACK message. So this is the complete flow. But before taking a look at the third and the final case, what we'll do is we'll go ahead and take a practical take a look at a practical demonstration of the entire CM0 commit mode 0 message protocol.
Subhashish,
Yes.
can I just ask
Yes,
you
Tom.
a quick question?
Sure.
On when you said that when the negative reply goes in because there's some issue, so that will go to back to the Connect client. And I think what you said was that the OTMA will perhaps requeue that. So does that mean that the connection is not lost between the Connect client and OTMA at that point, or does it have to reestablish?
No, that again, Dom, depends on whether a persistent socket is in use.
Right.
Yeah. So in fact, if you just take I have been talking about this persistent socket a lot for these 3 sessions, but if you just take a look at this particular screenshot, we have this in the second screenshot, if you take a look at this, in the socket type, we actually support a persistent socket, a non-persistent socket, and a transaction socket type. So I have in all my presentations, I have executed the transaction using a persistent socket. So in this case, it doesn't matter whether the particular unit of work actually succeeded or failed. The IMS Connect keeps the socket open for the next unit of work.
Okay, thank you.
Yeah, thank you. Thanks for the question. Good question. So yeah, let's understand the behavior of CM0 SL1. And as I'll just talk about the disclaimer before proceeding. So I have used BMC AMI Energizer for IMS Connect product in order to demonstrate this behavior. And my intention is not to do a sales speech of the product, but instead, I am using this product because I am a product manager looking after all the BMC AMI IMS products. And BMC AMI Energizer for IMS Connect is one of the products that fall under my purview. So quite understandably, I get to use the product readily and for free. That's why I always prefer, taking the screenshots or executing transactions, OTMA transactions, using this particular product. So if you just take a look at the 2 screenshots, I have executed the part transaction. So this is the installation verification procedure transaction that gets installed by default when you install the IMS Transaction Manager software, right? So this is a default IBM provided IVP transaction. So I have executed that transaction, and let's take note of some noteworthy options here. So for example, the first one is I have selected the protocol as CM0 commit send, which is the exact commit mode that we are trying to talk about today. And then I have selected the confirmation option as confirm ACK. And this is the synchronization level SL1. And is there anything else that I should talk about? No, I think these are the most important options. Yeah, and so now let's try to break down the transaction execution output. In the first part, which is pretty simple, the transaction is the part transaction is sent out to IMS, as you can see over here. the part transaction is sent out to IMS. And if you want to take a look at the actual message that gets sent out, this is the actual message that gets sent out to IMS. And then in the second part, IMS has sent the reply back to the client, right? So, this is the output of the part transaction. It's a washer part and things like that. This is the response time that it took for IMS. It took for the IMS Connect client to receive the response back from IMS, going through the entire steps that I talked about. And then the CSM is okay. The complete status message segment is okay, which indicates that, in simple terms, the processing till now is okay. And over here you can see that the flag is set to ACK or NAC required. So this denotes SL1. In the third part, you can see that the client has sent out an ACK message to OTMA. You can see over here sent ACK, and this is the actual message that gets sent out. And this C1 and A, these two indicates that this is an ACK message that has been sent by the OTMA client to OTMA. And in the fourth part, in the fourth part, you see that the IMS Connect client has received no data. And if you are wondering why that is the case, it's because, remember, for CM0 SL1 ACK and also for CM0 SL1 client NAC. So in short, basically for the CM0 message protocol, the client doesn't expect any message from IMS Connect, except for the output reply message from IMS, which has already been received, right? Please refer to slide number 8. I'm referring to this slide, right? So apart from the reply message, the IMS Connect client actually doesn't expect any message from IMS Connect or IMS or OTMA for the CM0 protocol. However, if you compare this with the CM1 SL1 ACK output, so I'm just flipping the CM0 to CM1. If you remember that in my previous session, I talked about the IMS Connect client or the OTMA client actually expects a deallocate confirm message. Because it's an ACK, the IMS Connect client actually expects a deallocate message, and for an ACK, it's a deallocate confirmed message. For a NAC, it's a deallocate abort message. So for CM1 protocol, CM1 SL1 protocol, the IMS Connect client actually expects a deallocate message from IMS Connect. Otherwise, it cannot go ahead and process the output message. But for CM0 SL1 protocol, the IMS Connect client isn't expecting any other message from IMS Connect except for the output reply message. And if you think about it, it makes sense because CM0 protocol stands for commit, then send. So IMS has already ensured that the unit of work has been committed from its side. So it knows that everything has worked perfectly okay. And after that only IMS has sent out the reply message to the IMS Connect client, right? So this all actually makes a good deal of sense. And I've just noted the differences in case of CM0 SL1 client NAC. So till this slide, I talked about CM0 SL1 ACK. And in this slide, I'm just noting down the differences which would be in place for CM0 SL1 client NAC. So on the interface screen, the difference only difference would be that I would, instead of selecting confirm ACK, I would select reject NAC. And then first, second, and fourth part of the output will actually remain the same. In the third part, the client will actually send out a negative acknowledgement message or a NAC message to OTMA. So this D5 and N indicates that the IMS Connect client is sending out a negative acknowledgement message or a NAK message. Okay, so that is all about CM0 protocol. And before I end this entire series of discussion on message protocols, I just wanted to touch upon this third and the final case, which is neither related to a CM1 or a CM0. What I'm trying to say is it doesn't matter whether it's a CM1 or a CM0 message protocol. I'm talking about a generic case here where an IMS Connect client sends an input message to IMS Connect, and the input message is nacked by OTMA. So if you can probably guess, the IMS application program even doesn't come into picture for this particular case, right? So let's go through the steps. So the IMS Connect client sends an input message to IMS Connect. Pretty simple. The the initial steps are going to be similar. IMS Connect will allocate an SVT control block for the client if the SVT control block doesn't already exist. And IMS Connect will then send out the input message to IMS OTMA through cross-system coupling facility, XCF, right? And then OTMA, after receiving the input message, it starts processing the input message, but one or more errors or one error or more than one error could occur. So some examples of such errors could be, things like, let's see, maybe an invalid transaction code or a stopped transaction, or maybe a security failure, right? An expired message maybe, or a TPI flooding. So these are some of the scenarios that could actually result in errors on the OTMA side. So as you can probably understand, the next step would be if OTMA, if no errors would have occurred in the OTMA code, the next step would have been the IMS application program. The OTMA would have what do you say, inserted the input message into the IMS message queue, and then it would have enqueued the message on the transaction queue, right? So that those would have been the natural steps if no errors would have happened on the OTMA side. But now, due to some reasons which I have talked about, maybe invalid transaction code or security failure or transaction was stopped, errors happened on the OTMA side of things. So in that case, the IMS application program doesn't even come into picture. OTMA will straight away go and NAK the input message with a sense code, what is called, OTMA will NAK the input message with something which is called a sense code and a reason code. And these are the fields TMAMC, SNC for sense code, and RSC for reason code in the OTMA header. And then OTMA will send the NAK message to IMS Connect through XCF, and OTMA will delete the transaction instance block or the TIB control block if it was allocated. And IMS Connect will send out an error message to the IMS Connect client, right? And again, if a persistent socket was in use, IMS Connect will keep the connection open and it will not free the SVT control block. Otherwise, the SVT control block will be freed. And then finally, the IMS Connect client will process the error. Now, I was talking about this IMS Connect will send the error message to the IMS Connect client. So if IMS Connect sample user message exits are in use, you will see there, you will see this REQ STS error message. I'll show you what I mean by that. So if you take a look at this screenshot, over here, if you see the IRM header section, message ID, I have used, and this is a user message exit which I have used. So this is the sample message exit. So this is the IMS Connect sample user message exit provided by IMS Connect by default, right? So there are, I guess, if I remember, I guess there are 4 default IMS Connect sample user message exits, and there is one for Java, and then there are 3 others for native transactions, right? So if you are using one of these IMS Connect sample user message exits, you will see this error. If I can find something out for you. Yeah, if you see over here, this REQ-STS, so this states that this states that something, the message is not a result of some normal processing. It's something other than return code 0. So you can see over here, it's return code 4. So it's treated as something not normal. And if IMS Connect sample user message exit is used, this REQ-STS header, if you can call it header, you can track down this particular REQ-STS header in the IMS message sent. I think yes, that actually completes the entire process. And with that, I'll say that I've been able to complete the entire OTMA message protocol section with that. So with that, I'll wait for questions, and then I'll also pass the control back to Dom at this point. Dom, if you may want to take it away.
Yeah, sure. Thanks, Subhadesh. That was really useful. I've got a couple of questions, but obviously anybody that's got a question now, just if you just unmute yourself, and then you can ask that verbal question. But I've just got a quick question on, on that negative acknowledgement where you had described the one where you get an error back from OTMA. So that was the last scenario. And you were saying that it could be something like a security, or it could be like a stopped transaction with that error message going back with a NAC message. Would that also be the case if I was just trying to get my head around this? Is that also the case for if occasionally we've got online changes, ACB online changes happening? And then sometimes we do get the bounce back where OTMA actually goes back and bounces it back, saying we can't actually process that. So would that be the same scenario here, where it would do the error message and then the NAC going back?
I will think so, because at that particular point, what happens is what probably OTMA detects some malfunction, some error condition, and it doesn't allow the IMS application program to take control. So I'll say yes. Yes. It's most probably the case what you were referring to. Yeah.
I mean, there's usually an OTMA message, error message, and it goes back to the client, I think. So yeah,
exactly.
Okay.
I'm quite sure that is the case.
Yeah. I mean, we've had it before, so it's not. I'm just trying to be, open out the numbers of scenarios that we could get.
Right.
And then the other question I've got is, it just occurred to me that there's more on the SL1 scenario. That where you've got the request type with the messaging being you had it before on one of your slides where it's that situation where in zero mode, once the replies, we're saying that the IMS message is only sends the reply when it's it sends the reply only when it's completed, which is great. And then I thought, well, presumably there's more overhead with the SM1 SL1 acknowledgement output, because you're doing a little bit more in this in the whole scenario. You're actually doing more communication. So do the applications, when they say, when we're designing and when we're saying let's use SM1 as opposed to SM0, would it be SM0 if you want a quick acknowledge, the application being quick, as opposed to going to the nth degree to say, well, can we do this bit, can we do that bit? So that because there's more legs to the SM1, are people designing their applications because they want it fast and they want the acknowledgement from IMS coming back and say, right, well, we'll go for SM0 for this type of application, as opposed to SM1, where we have some of the we have the request status going back before the whole completion. So I don't know whether I've explained that very well, but what I'm trying to say is it more performance related where it's SM0 as opposed to SM1?
I'll agree with you, Tom. I will prefer, I always prefer CM0 SL1, as compared to CM1 SL1. That's because if you remember, when in CM1 SL1, when IMS OTMA sends the reply message to IMS Connect, and IMS OTMA is actually waiting for an ACK or a NACK from the IMS OTMA client, at that point, the sync point processing, the database logs, and external subsystem logs, which may be DB2 MQ logs, are all held. And even at that point, the message processing region or the MPR remains occupied, right? So there is a significant amount of resources that is held simply because OTMA is either waiting for a positive acknowledgement or a negative acknowledgement back from the OTMA client.
Okay.
So you are holding a significant amount of resources. Compared to that, if you look at CM0 SL1, it's quite straightforward. IMS does the sync point processing. It completes the commit process first. Once it's sure that the commit process has ended successfully, it then goes ahead and sends the reply back to the IMS Connect client.
Okay, yeah.
Brilliant. So the performance, I will say, is definitely, from a performance perspective, absolutely CM0 SL1 rather than CM1 SL1.
Okay, thank you very much.
Yeah, thank you. Thanks.
Okay.
That's a good question, actually, Dom. Yeah.
Okay. And so if we've not got any more questions, obviously, if you've got any questions, then please ask by just unmuting yourself. If not, that's fine. And just to wrap up then, so this session is 5M. So if we just put the last foil on, maybe Subhadash, that'd be great. And there's obviously a QR code to give your feedback on this session, and that would be gratefully received. And so we've got the QR code in the bottom left of the foil, and we've got the link as well at the middle there. So, and its feedback is the session 5M. So well, we did have actually two people. We've had Santos joining about a third of the way in, which is great, and so that's one of my work colleagues, and we've also had somebody else joining for a short time as well. So we didn't have nobody on this session, which is apart from myself and yourself, Subhadash. So thank you very much for all three of those sessions. They were useful, and what we'll say is we've got the slides are there to download now, and then the video will be available at sometime in the near future, and that will be uploaded to the website for people to view for at least a year, and then apparently it goes on YouTube after that. So we'll look forward to that. But thank you very much, Subhadash, for doing this session. and thanks audience for participating, and we'll look forward to the last session, which is going to be on STEPS, which is going to be at 10:30 UK time. But thanks very much for everybody for your attendance, and thanks to Badash in particular for doing these 3 sessions with us over the course of this virtual conference. Thanks very much all.
Thank you. Thanks, Tom.
Cheers.
Thanks to the audience as well. Thank you. Bye.
Thank you. Bye.